Okay, so Mike had a question right before we left about question 2244. The question was, how can we synthesize this molecule from benzene? There are two ways to do this. Probably the most straightforward starts with a single bromination of the aromatic. So we're going to take Br2 and some sort of catalyst. FeBr3 is the kind of common one for this reaction. And we're going to install a bromine onto the aromatic. By installing a bromine onto the aromatic, we can now create a Grignard, which we can add on to any sort of carbonyl group. We also need to make the carbonyl group in such a way that we can add on to it. Perhaps the easiest way is to take the alcohol, since we can use any alcohol of our choosing in this reaction, and oxidize the alcohol all the way up to chromic acid. A common oxidant, although not the only one we could choose, would be chromic acid, like H2CrO4. I'm going to use KMNO4 because it is a strong oxidant and it's a relatively simple molecule. Potassium permanganate can oxidize and it's much safer to use. And since I'm in the basement of my own home, it's important to use safe molecules. At the end of this, we use an acid, H+, because potassium permanganate is always in base. It's a basic condition oxidant. And so we'd make the carboxylate. We want to make sure that we end up with a carboxylic acid. That carboxylic acid can't react directly with the Grignard because the carboxylic acid is acidic and the Grignards can easily be quenched by that acid. So we are going to use SOCl2, thionyl chloride or SOCl, in order to convert the OH here to a acyl chloride. The acyl chloride can react very easily with the Grignard. If we react 2 times with the Grignard, we end up with the intended product after an acidic workup at our second step.